Okay, with all these proofs, what we're really looking for is a vocab word. That's why this is our vocab proof packet. So what's our vocab here? Well, it's complementary. So look down your sheet if you need to. If you're getting started in these, take out that sheet, look for where we have that vocab word. And I think you're only going to find one. It's definition of complementary angles. Well, a lot of these are like that. Not all of them, but if you have complementary, probably going to use a definition of that and say, well, by definition, what does it mean to be complementary? What can we say? So look at the conclusion of your conditional statement there. We're going to use the law of detachment in all of these proofs to say if you've got a specific condition satisfied, go ahead and make that conclusion. That's the law of detachment. So what does that conclude? Well, it says that the measures will add up to 90. So in this case, if 1 and 2 are complementary, well then measure of angle 1 plus measure of angle 2 will equal 90. If 2 and 3 are complementary, well then measure of angle 2 plus measure of angle 3 will also equal 90. And you can actually say that in the same step because we're using the same reason. That's all they gave me. Somehow I'm supposed to show that 1 and 3 are the same. So what can we do? Do we have anything else in the picture? If not, we need to try to fit these two equations together. We have angle 2 a couple times, we have 90 a couple times. So maybe we could replace one of those for the other. You could actually solve for measure of angle 2 in one of these and replace it. But since 90 is the total, or it's solved for both of them, I think what I'm going to do is I'm going to use that. I'm actually going to rewrite. It doesn't matter which one, except I know that angle 1 is going to be on the left when I'm done. So I'm going to use the angle 1 on the left here. Measure of angle 1 plus measure of angle 2 equals 90. But instead of writing 90, I'm actually going to replace that with something. Or you say erase and replace all the time. Really, I'm going to erase the 90 and replace it with, what can I actually replace it with? Well, it also is the same as the sum of 2 and 3. Which makes sense. If those two sums both equal 90, well then the sums are going to equal each other. And what we're doing is we're replacing 90 with the sum. That's replacement rule. Are we going to be able to show that 1 and 3 are the same? I have a relationship, one single equation that has both of them in it. If that's going to be true, the 2's would have to go away, which they're the same thing, they should. We'd actually be subtracting the 2's from both sides. Not, I mean, you can say canceling, but it's not like you're actually canceling. Really, we're subtracting it from both sides of an equation. You don't even have to write that down. I just like to do that when you guys are watching these videos because you'll follow it better, I think. If we subtracted this from both sides, we'd get nothing there except for the measure of angle 1 on the right. We'd only end up with measure of angle 3. So what property says that you can just subtract something from both sides of an equation? Look for the one that's adding or subtracting. There's a word for adding or subtracting. It's additive. And in this case, it's additive property of equality. Or actually, instead of writing that out, I'll just say APE, additive property of equality. You can add or subtract something to both sides of an equation. If you needed to switch the order of what we just got, if it was 3 to 1 instead of 1 to 3, maybe look for that property. What property would you use to switch the order if we needed to? It's symmetric. S little ype, symmetric, which kind of is what symmetrical means, so that's kind of nice to help us remember that. But it's the symmetric property of equality. As it is, the only thing I have to do is change from measures are equal to congruent. So what does it mean to be congruent? It means all the measures are the same. So to prove something congruent, you have to show me all of the measures are equal, which in an angle, there is only one measure. So by definition of what it means to be congruent, you've shown all the measures you need to. We can say they're congruent, and we justify that by saying definition of congruent angles. Angle 1 is congruent to angle 3.